Hi, folks. Let's talk a little bit about the difference between mass and weight. And why we're going to spend some time on this is because in common everyday language, we usually do not differentiate, but in science, this is a big deal because they are not the same thing. Now, mass is defined as the amount of matter in a substance, how many atoms are packed how close together. The units we use to measure mass are going to be grams and kilograms. And the tool we use to measure mass is a balance. In the old days, it was called a balance because you would compare a unknown thing to a known quantity of mass, and if they balanced, then you knew exactly how much of your unknown quantity you had. In modern chemistry labs, you're going to see an electronic balance, and it is a much simpler process, but it is going to be measured in kilograms or grams, and that's all has to do with exactly how many atoms are in that material. Now, weight is different. Weight is actually a measurement of the force of gravity on an object. And that's going to change when gravity changes. And you say, well, gravity doesn't change that often. Well, in science, we look at gravity in a whole variety of different situations, different planets, distance from the center of the earth, etc. The units that you and I use when we step on the bathroom scale in the morning, those are pounds, and those are actually weight units. In the metric system, it's going to be newtons. The tool that's used is called a spring scale. In your bathroom scale, there are typically little springs, and when you step on that bathroom scale, if you have a digital scale, those springs are going to give you a digital reading that's going to be translated to a digital reading. But I don't know about you, I do not jump on my bathroom scale in the morning. I step on it very gently because I don't want to add a pound or two for jumping. I am very delicate when I step on that. So it's a different sort of thing. The other thing that's very different between mass and weight is that mass stays the same wherever it is measured, and weight's going to change, as I mentioned, when gravity changes or you change your location. So let's go through a couple examples. The astronaut example, traveling to a different place, is the easy one. Let's say an astronaut has a mass of 100 kilograms and weighs 980 newtons on Earth, goes to the moon. On the moon, your weight will be 1/6. So mass of 100 kilograms or weight of 162 newtons. To put it another way, if you have a weight of 120 pounds on Earth, if you go to the moon, you would only weigh 20 pounds. But that doesn't mean that your blue jeans are going to fit any differently. You're going to have the same number of atoms inside your body. Your clothes are going to fit the same. But the pull of gravity on you is going to be different. Here's another example traveling between the Earth and Mars. Mars is a much smaller planet than Earth, so if somebody weighed 110 pounds on the Earth, they would only weigh about 42 pounds on Mars, but mass, how many atoms inside your body, would be the same. In chemistry and physics and science in general, we most often are going to talk about mass in grams or mass in kilograms because we care about the amount of matter in a sample when we're actually looking for quantity of stuff. That's what we're most interested in. In physics, sometimes we're also going to be looking at forces, and that's another talk for another day and another subject. But if we want to know quantity of how much we've got and we're measuring it in grams or kilograms, we're going to use the term mass and we're going to measure that on some sort of a balance. The other reason this is very, very confusing is because you and I live on planet Earth. Our gravitational field on our planet is pretty steady from one place to another. If you live in the Rocky Mountains or you live in the plains or you live near the seacoast, anywhere on the planet, our gravitational field's pretty steady. And because that, there's a nice steady ratio between mass and weight. And when you buy a product, often it will give you weight in pounds and mass in kilograms and treat them like they're the same thing. They're not the same thing. And the scientist in me makes them crazy. I found this image online, and this is a typical example of why this is nuts, because it will say this bag of flour is 5 pounds or 2.27 kilograms. They're not the same, but you're the smart one now because you're taking a science class and you understand mass and weight are not the same. I also wanted to point out that bad science is all over the internet. I found this picture and it says, how much would the average person weigh on each planet? And it gives a nice difference of weight in pounds. And then it changes their mass from place to place. Bad science, bad science. See you later.